All right, chapter 92 is all about uniform motion problems, and these are the classical algebra problems that you see when you watch a TV show and some kid on the TV show is taking an algebra class. Two trains leave Philadelphia at the same time. One's traveling east at 90 miles an hour, the other's traveling west at 60 miles an hour, and so on and so forth. And the mom and dad get all crazy because it's the hardest thing they ever saw in their life. And anyway, that's what this is going. That's what's happening here. All right, we're not going to have trains leaving Philadelphia in this case. We do have a freight train and an express train. But what's going to happen to the problems today is the distances are going to be equal to each other. So every single problem that you see involving some vehicle going at some speed for some amount of time is going to be distances are equal to each other. That's the good news. The bad news is it creates a bad habit if we think it's going to be that way every single time. So what I want to do is start looking for some terminology in the problems that helps us to establish that that's happening. And the words that make that happen here is made the same trip. All right? The express train made the trip. The freight train made the same trip. If you make the same trip, that means you're going the same place, right? You're going from point A to point B, the same place they went from point A to point B. So if I'm drawing a picture of what that looks like, here's what my picture is going to look like every time I draw it. I draw arrows representing the direction people went and how far they went. And I don't know how far they went, do I? It doesn't tell me. All right? So the express train made some trip. There's the trip the express train made. How far did the express train go?
We don't know.
It doesn't tell us. So I'm going to use a variable d subscript e for the distance the express train went. And then I'm going to draw that the freight train made the same trip. That's what it says, right? So if the freight train made the same trip, it went from the same point A to the same point B. It also went some unknown distance. That's the distance the freight train went. When I'm drawing that picture, I couldn't care less about speed or time. I only care about distance, and I don't know anything about distance. I don't know how far they went. All I know is they went the same amount of distance, right? So what I get out of that whole thing is that the express train distance is equal to the freight train distance. Every problem you get as of right now, before we get to less than 94, is going to be that scenario. The distances are going to be equal to each other. Okay, there's different ways to make distances equal to each other. That's one of them, where people make the same trip. I want to see the picture. I want to see the distance relationship. Now, you can see here I've made this chart here. Rate, time, and distance are the columns, and the horizontal categories are express and freight, because that's the two things happening in this problem, right? We have an express train and a freight train that are going places. Okay, the next thing I want to do after I figure out this right here, that the distances are equal, is I want to figure out the rates and times of both of the vehicles in the problem. When I read the problem, that's all I care about when I'm reading the problem, when I'm trying to fill out this chart. How fast do they go, and for how long do they go that fast? They're either going to tell me, or they're going to give me some kind of relationship. Somebody went faster than somebody else. Somebody went for more time than somebody else. Whatever. They're going to either tell me specific stuff, or they're going to give me some information to give me the ability to use one variable to represent more than one thing. So, what is the time of the express train?
12 hours.
And we're dealing with hours. I'm going to put units up here. So anytime I get a time, we're talking about hours. How long did it take the freight train to make the trip? 16 hours. If they're going the same amount of distance and the freight train took less time, the freight train took more time, who's going faster?
The express.
The express train's going faster. Not just because it's called the express train, it took less time to go the same distance, therefore it must be going faster, right? That's how it works in a car. You push the gas harder, you get there faster, unless you get pulled over, in which case it might take more time. Don't get pulled over because you're going too fast. There's my disclaimer for the day. Do not drive too fast on the road, or you will get pulled over maybe. All right. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So, if I'm going to put an R for the rate of the express train. The rate of the freight train is 15 kilometers per hour less. So that means the same rate minus 15. If it's less or more, put the letter, then plus or minus the number. All right? And what's the unit of rate? Kilometers
Per hour.
per hour. So kph would be how we typically write that, right? And if kilometers per hour is the unit of rate and hours is the unit of time, what's the distance unit?
12 hour. I mean, kilometers.
Kilometers, right? Okay. So, reading the problem, I can very clearly establish exact time of both vehicles and algebraic or abstract rates, but related because they use the same letter to represent both speeds. If this is 20, this will be 5. If this is 40, this will be 25. If this is 100, that'll be 85. Okay, so we have the ability, if we know one, we can find the other, right? Once you know the rates and the times, rate times time equals distance. That's how we fill in the distance expressions. Okay, so again, I read the problem to find out these 4 boxes. I multiply this times this to get that. What's r times 12?
12R.
12r. And what's r minus 15 times 16?
16R minus
20. Just kidding.
40 something.
240? 240, all right. 16r minus 240. It says r minus 15 is a binomial. I have to multiply 16 times both pieces. 16 times r and 16 times negative 15. So 16r minus 240. These two things that I have written in these distance boxes are the distance of the express train, which is d sub e, and the distance of the freight train, which is d sub f. We've already got this structure for an equation written here. So I'm just going to take these two expressions we got and I'm going to set them equal because that's what that says. So the express train distance, 12r, is equal to the freight train distance, which is 16r minus 240. Whatever goes in these two boxes goes into this equation structure we created up here. That gives me an equation with a variable. The variable in this case is r, so now I need to go ahead and solve for r. I subtract 16r, so all the r's are on the left. I get negative 4r is equal to negative 240. Divide both sides by negative 4, I get r is equal to 60. Okay, now, first off, I used r for the word rate. I could also use s for speed if I wished. S's look like 5s, r's look like r's, so I like to use r for rate, that's what I do. If you want to use x every single time, I don't care, it doesn't matter. I like to use r's for rates, t's for times, that's what I like to use. But again, it doesn't matter what variable you use so much as you do it correctly. Now the last thing you have to do on these problems is very important that you answer the question. Okay, I've seen a lot of people get to this point, they're correct, but then they didn't answer the question. So the question says, find the rate of each train. What does R represent?
The express.
The express train rate, right? So another purpose of the chart, other than just organizing all our information, is once I get an answer, I can use that chart to represent what the answer represents. So R equals 60 goes here. 60 is the rate of the express train at 60 kilometers per hour, right?
So 60 minus 50.
So I put R sub E is equal to 60 kilometers per hour. R sub F is the other train, right? The freight train. And to find that, I'm supposed to take 15 miles per hour off the express train, right? 60 minus 15 is equal to 45. If you want to use subscripted variables to represent things, you're welcome to do that. You can also write express, R equals, freight, R equals. I'm fine with R sub E and R sub F as far as identifying what they're asking us to find. That's the whole process in these problems. A very systematic way of doing it. Start with the picture to get the distance relationship. The way the problems differ is the distance relationships. Today they're equal. The next time they're going to add up to a number. The third time, one distance plus number equals the other distance. Okay, those are the ways they're going to set them up. So this makes each problem different. So that's the beginning point. What kind of problem is it? Second thing, rates and times. Third thing, create distance expressions that substitute in, solve to get an answer, use that answer to find whatever they're asking us for. How long was the trip? That's another question I might have asked here. 60 times 12 is 720 miles. 45 times 16 is also 720 miles. Distances should be equal, right? Or kilometers instead of miles, sorry. So anywhere you see a letter represents something you don't know, so that's something they might ask. So make sure that you don't satisfy yourself with, this must be the answer I'm looking for, because I did some math problem and I got an answer. Make sure that that answer answers the question or find all the answers we're looking for.